Hey, everybody, let's talk for a second about how to do math with significant figures because there's some special rules that you need to know, and this video is going to teach you them. So, first of all, it's important to recognize that really what significant figures does mathematically is it tells you where to round numbers. And it's telling you how to round your numbers so that you aren't artificially increasing or decreasing the accuracy of your calculations because your calculated anytime you're doing a calculation with real measurements that you've taken, the answer to that calculation has to still reflect the same amount of accuracy or precision that those original measurements had. So that's really what this entire effort is going towards, is maintaining accuracy and not suddenly ending up fabricating extra accuracy in your calculations when your original measurements didn't have it. So, quickly, the rules of rounding are that you need to find where the last significant figure in a number is that you get to keep, and then you're going to look at the number to the right of that last significant figure. If that number is a 5 or greater, you're going to round the last significant figure up, and that's going to be where your number ends. If the number after this last significant figure is less than 5, you're going to round the last significant figure down, or in other words, leave it the same, and that's going to be where your number ends. Now, I do want to point out that some people may know more complicated rules, especially regarding fives. Technically, there are some more advanced rounding rules, but we're going to stick to these ones because these suffice for our purposes for the moment. So let's really quickly just review rounding. If I wanted to round this to three significant figures, what I would do, let me get the marker out here. What color should I use, everybody? Pink is what I heard from the crowd. All right. So we are going to start at the beginning of the number and count out three significant figures. Well, this 2 is significant, this 6 is significant, and this 0 is significant because it's a sandwich 0. So this is my last significant figure. This is where my number is going to end, right? I'm going to cut it off there. But first, I have to look at the number that follows that last significant figure. And if it is a 5 or greater, I have to round the last significant figure up, which in this case, it is. So the number is going to end up rounding to 26.1, right? That third significant figure rounds up. So, really, what you need to know, and this is the trickier part, is depending on what kind of mathematical operation you've done, where do you round your number? Where is that last significant figure? And there are two different rules, one for addition and subtraction and one for multiplication and division. We'll start with the addition and subtraction rule. When you are adding or subtracting numbers, your answer has to have the same number of decimal places as the original measurement with the fewest number of decimal places. So you want to stick that bolded statement in your mind. For addition and subtraction, it's the fewest number of decimal places. Let's do an example. And feel free to pause the video if you want to try this out and then hear the answer in a second. Before we even get started, this number, 43.21, has two decimal places. And this number, 1.927, has three decimal places. So based on that rule we just went over, our answer is going to be limited to two decimal places because our number with the least number of decimals has two decimal places. So in this case, if you plug this into your calculator, you're going to get 45.182, but really the answer is 45.18 because you're limited to two decimal places. And then you're going to stop there. Let me bring out that pink marker again. You're going to stop there. That's where your number ends, but you've got to look at the thing, remember, that follows the last significant figure to determine rounding. In this case, it's less than a 5, so that 8 is not going to round up. It's going to stay an 8. And so the answer is 45.81. Let's do one more, this time a subtraction problem. If we plugged this into our calculator, we would get 7.6975. But if we were to actually report that in, for example, a lab situation, that would be misrepresenting the data because this number cannot be exact to that many decimal places. And the reason is that the measurements weren't exact to that number of decimal places. we're limited by the least accurate measurement. In this case, the least accurate measurement is 2.5 that only has one decimal place. And so you're only going to be able to keep one decimal place. So this 6 is going to be our final significant figure. That's where our number will end. But again, we've got to look at the thing that follows the last significant figure. In this case, it's a 9, which is greater than a 5. So the last sig fig, the 6, is going to round up to a 7. And so our real answer is 7.7. Now, what do we do when multiplying or dividing numbers? Well, this rule is a little bit different, but it sounds very similar. So it's going to be tricky to keep these straight in your head if you don't have them straight already. When you're multiplying and dividing numbers, the answer that you keep has to have the same number of significant figures as the original measurement with the fewest number of significant figures. So it doesn't have anything to do with decimal places. It's just the fewest number of significant figures in the whole number. So again, you want to remember the bolded statement. For multiplication and division, you're dealing with the fewest number of significant figures. Here's an example. If we multiply these numbers together, plug them into your calculator, you'll get 0.0321. But wait a second, can we actually keep that whole number? Well, we've got to think about how many significant figures our original numbers had. 3.21 has 3 significant figures, all non-zero digits. 0.010 is kind of tricky. These two leading zeros are not significant. The 1 obviously is, and the trailing 0 is also significant because there's a decimal in the number. So this has 2 significant figures. If this has 3 and this has 2, that means we're going to be limited to only having 2 significant figures. We get to keep the least. So we've got to round 0.032 to only 2 significant figures. Well, this is our first significant figure. This is our second. That's where the number is going to end. We've got to look at what follows the last significant figure. It's less than a 5, so the last sig fig does not change. It's going to round down, or in other words, stay the same. So the actual answer is 0.032. We'll do one more example. 10.1975 divided by 10.5 in the calculator is going to give you a big, giant, super long decimal. We're not going to keep the whole thing. If we did, if we were taking measurements in a lab and we reported this as as the as the answer to this problem, we would actually be fabricating data, right? It's not as bad as like just making up data off the top of your head, but fabricating accuracy in your data and in your calculations is it's scientific. It's false science basically. So it's really really important that you stick to these practices. Now 10.1975 has 6 significant figures, whereas 10.5 has only 3. So that means we're going to be limited to 3 sig figs. So again, we're going to find our first 3 sig figs. The leading 0 is not significant. So it's going to be these 3 numbers are our first 3 sig figs. That's where the number will end. What's followed by the last sig fig? Is it less than 5 or is it a 5 or greater? It's less than 5. So the last sig fig does not round and we get 0.971 as our final answer. And there you have it. That's an overview of the rules for how to do mathematical manipulations and still keep the right number of significant figures. This is something that will stay with you through the rest of chemistry. So feel free to watch this video at any time if you need a reminder. Hopefully that helped you out. Until next time, take